All right, welcome, my 7th graders. So today we're going to start chapter 8, and it's just prior knowledge, okay? Because I want to review some topics that you guys might not have seen for a while, or maybe not seen at all. So this is all about volume and surface area of 3D objects, okay? Which volume and surface area tell you automatically that it's 3D objects, but just in case you didn't know. So if I have a rectangular prism like this guy down here, in case you don't know what a rectangular prism is, because it's got rectangles on the sides, okay, and it makes this prism. The volume of that, which remember volume is how much it holds, what's inside of it, okay, is length times width times height, okay. Now sometimes the formula is actually written as the area of the base, which is, length times width of the prism times the height, or like a big B times H. So there's actually two ways. We can write it as length times width times height, or V equals the base, the area of the base times the height, okay? So you'll see it two different ways. So I want you to find the volume of this prism, okay? I'm not going to do it for you, so go ahead and pause the video, do that problem, and then come back to it, okay? And again, I'm going to find another volume of the prism. I'm going to do this one with you because this is the second formula, okay? So I have the formula V equals B times H, and the area of the base is 10 centimeters times the height, which is 5 centimeters, and this is going to be 50 centimeters cubed, okay? Because 1 centimeter and 2 centimeters gives me 3 centimeters when I multiply them, okay? So anytime you're dealing with volume, you're going to have some sort of cubic, okay? That's what's called a cubic, okay? You're always going to have some sort of cube here, whatever unit you're using, okay? So make sure that's included when you're doing volume, okay? Now, I want you to go ahead and find the volume of a cube, so not just a rectangular prism, but a cube specifically, with a side of 6 centimeters. How would I do that? Okay, remember a cube, those are perfect squares, right? Okay, so that means this side is 6, this side is 6, this side is 6. Okay, so that's the only hint I'm giving you. Go ahead and pause the video and try that one, okay? Now this one's a little different, okay? So it says find the side length of a cube with the volume of 512. So I have my cube again here, right? And they want me to actually find what is the 3 side lengths, right? If my volume equals 512. So if I look at the formula, length times width times height, okay, it's 512. I know conveniently here, these are all the same number because it's a cube, right? So I need to find 3 numbers that are exactly the same that give me 512. Now what this is actually called is called the cube root. So I could write these all as x's, and x times x times x we know how to write as x cubed, right? That's our exponents coming in. Now we didn't talk too much about cube roots, but what I need to think about is, first of all, start with your basic ones. We know that 3 times 3 times 3 is 27, because 3 times 9 is, or 3 times 3 is 9, times 3 is 27. 4 times 4 times 4. So let's experiment with this a little bit, okay? So 4, let's turn this on. 4 times 4 times 4, okay, is 64. 5 times 5 times 5, I happen to know it's 125. 6 times 6 times 6, okay? I don't know that one off the top of my head. I did know 64, but for some reason I was being slow and didn't want to do it. 216, so I still have to go a little bit bigger. I'm thinking 7 is going to be my jackpot here. 7 times 7 times 7. Oh, no, I was wrong. It must be 8. Apparently it's been a while since I've had to practice my cubes. Whoops. 512, in case you didn't see that, okay? So the side length is 8, right? Now there's other ways to figure this out that are a little more complicated. I'm not going to go into that, but if you'd like me to practice with you, you can. But the side length are going to be 8 centimeters, right? Because I took the cube of this, so I get rid of the cube. So it's just 8 centimeters for each side of my cute little cube here. Okay? All right, moving on. Well, this one's a little complicated, but I think you guys can handle it. So it's the surface area of a square pyramid, and what a square pyramid is the base is a perfect cute little square here, and the rest is triangles, right? So like a pyramid, a regular pyramid that you see, but just the base is a square. Okay? Now S stands for the side of the square, so like this is S, L usually stands for the slant height, okay, so the height that's kind of on this diagonal. And then H usually stands for the total height here, okay. Now remember, surface area is like the amount of area of wrapping paper I would need to cover this guy up, okay. So if I laid this all out flat, what would the area actually be? Volume, remember, is the inside of whatever we're talking about, okay. So if I think about this, I have one triangle. I have this back triangle, right? If I look at that back triangle there. I have this other side triangle in green here. Oop, my green isn't working very well here. And then I also have my yellow triangle right up front here. Okay, so I have 4 triangles, and they're actually all the same area, okay? And how do we find the area of a triangle is 1/2 base times height, right? My height is the slant height, and they tell me the base down here, right? Because if I looked at this triangle, that's how I would find it. But there's 4 triangles, right? We just said. So I multiply this whole thing by 4. Well, to make my life slightly easier here, I'm going to draw lines so you're not confused. 4 times 1/2 is 2, right? So I get 2 times the base, which we're calling S, times the slant height, which we're calling L, right? So in my formula here, that's where this 2SL is coming from, okay? Now I also, if I'm wrapping this with wrapping paper, I'm going to talk about the base, right? So the little starry base here is this cute little square, right? How do I find the area of a square? Okay, so this is the triangles. My square, I know you guys can't see what I'm writing when I zoom out here, is there. To find the area of the square, that would just be S squared, right? Because S times S gives me the area of a square, of a flat square. So when I add these two up, S squared plus 2 times S times the slant height, that gives me the surface area for this cute triangle. Angular prism, I should say, not triangle. Triangular prism. So that's where this is coming from, okay? So again, if you don't want to remember all of this stuff, that's fine. You can just keep the formula with you. I would let you guys have a note card on this test where you can just have this written down. But this is how you can get the formula if you were to ever forget it, okay? And I just wrote this little note here, okay? So I want you to find the surface area of this cute little triangle here. Again, it's not a triangle, I'm sorry. Triangular prism. Cute little triangular prism here, okay? Remember the S here is 6 and slant height is 5, so do some plugging and chugging, okay? So S equals 6 and L equals 5, and find out what that is, okay? I'm not going to do it for you. Next is area of a circle. This one you should memorize, okay? You're going to use it so often in all your math classes. The area of a circle is pi r squared, okay? And r stands for radius, right? Okay. And remember the diameter is half of the radius, right? I'm sorry, diameter is twice the radius. I apologize, twice the radius. Goodness gracious. Twice the radius. The radius is half of the diameter. Apologize for that. So I want you to find the area of a circle with a radius of 4, okay? So we have pi r squared. And also, so this is like 2 problems. Okay, so we have pi r squared with r equal to 4. But this one I have pi r squared and d is equal to 10. So how do I find r? Okay, what is r going to be? And then go ahead and solve those. So this will be another good time to pause the video and work through that, okay, for me? Thank you, thank you, thank you. And I have one more thing for you, okay? They're going to talk to you about what's called the net of a solid, okay? The net of a solid is if I were to take, let me see what I have here. I have a box of granola bars here. If I were to take this box, which we can agree is a rectangular prism here, I'll zoom out a little bit. Oh, I'm already zoomed out. Okay, it's got rectangular tops and bottoms. If I were to actually flatten this box out completely, so give me 10 seconds. I'm doing this on the fly. I wasn't planning on doing this. Okay, if I were to flatten this box out completely, and it's being a little fussy right now, this is kind of what it would look like, right? Now, there's some extra sides here because I wouldn't actually use this side. I know you guys can't see this very well, but so if I were to flatten this all out, this is what the net of a rectangular prism would look like, okay? So basically, if you unfolded it all and it was flat, what would it look like? So you guys can see these pictures probably better on yours, but if I were to fold out the cube, okay, I would have the square faces. I'd have 1, 2, 3, 4, 5, 6 square faces. So that's what's called the net of a cube. The net of a rectangular prism, which you kind of just saw with my granola bar box, Okay, if I were to flatten it out, you know, this would be the end up here. I'd fold this, and these are all my little fold lines, okay? So it's kind of like origami. This one would be a triangular prism, okay? So this would reach up to be the cone part, right? Okay. And this would overlap it to be the sides of the point, okay? And this would be a square prism, okay? And you should notice that this is the square part right here, right? And these would fold up to be the points of that square pyramid, okay? So we're going to talk about that a lot in this part of the chapter. So just remember, net means if I fold it all out, what would it look like? These are some problems for you to practice again, okay? If for some reason you finish, which many of you will, I'm sure, your options are to either work on your project or some Khan Academy links, okay? If you need me to assign you a Khan Academy link, please let me know and I will be happy to do that, okay? No one should be up in another seat doing nothing, okay? And if you are, I'll find something for you to do, okay? Have a wonderful day. We'll talk to you tomorrow. Bye-bye.